Welcome to the Allen Resources video seminar series. My name is Fernando Diaz, and I'm the Whitman Associate Professor at the Whitman School of Management at Syracuse University. And I'll be with you today talking about derivatives. Let's start out by talking about controlling risk with derivatives. Specifically, let's talk about the advantages of doing this with futures contracts. And I have here 4 advantages that are perhaps the most important ones. One, managing risks using futures is extremely cost-effective, and an example of that is the fact that with a futures contract you control large notional amounts with very little money. That is, very small amounts of margin that range between 2 and 10% of the value of the contract. So, for example, the S&P 500 futures contract at a futures price of 1,000 has a notional value of $250,000, and you can control that much notional exposure with only about 10% money in margin. And remember that margin actually can be posted in interest-bearing securities, so that it's even more cost-effective if you look at it in that respect. The second reason why futures contracts, or the second advantage of futures contracts, is that it's very easy to short. It's as easy to short, that is, enter into a contract to be the deliverer of the underlying, than it is to buy or enter a contract to be the party that takes delivery of a contract. So, and this is extremely important, the ease with which you short, to use this derivatives in hedging, because oftentimes you have to hedge a long position, and you do so by entering a short position in the derivative, and entering short positions in the futures markets is extremely easy to do. The third advantage is that these markets are very liquid, generally are very liquid. Specifically, the markets that are most used to do this risk management, the equity markets, the S&P 500, the fixed income, the T-bond, the treasury bond futures, or the euro-dollar market. These are very liquid, meaning that there's always a buyer or a seller for the exposure you want to manage in the market. And finally, these markets are also generally deep, which means that you can effect some relatively large transactions in these markets having very little price impact. These are, of course, then the 4 most important advantages of using futures, the derivative, to control or manage risks with them. Let's now talk about duration. Duration, the definition of duration is that it is the average maturity of the cash flows of a bond. So let's intuitively understand what that means. Let's suppose that we have a 1-year bond that pays 2 coupons, one every 6 months, one the first 6 months, the other one at the expiration of that bond. And the other cash flow that it pays is face value at maturity. So obviously, the first coupon, or the first cash flow paid by this bond, is before the actual expiration of the bond, before the 1 year. And if you average the times weighted by the cash flows of this bond, then you'll find that the duration, which is the average maturity of the cash flows of a bond, will be slightly less than 1 year, because there's a cash flow that happens before the end of the year. One cash flow happens in 6 months. Now, technically, duration is equal to the change in the bond price divided by the bond value, multiplied by 1 plus the yield of the bond, the yield to maturity of the bond, divided by the change in the yield of the bond. Now, there are 2 things that you have to remember about duration. One is that duration is a positive number, because it is the average maturity of the cash flows of the bond. So that is a positive number. And the second thing you have to remember is that it is always, or generally, less than or equal to the time to expiration of that bond. So remember, duration is a positive number, and the duration is less than or equal to the expiration of that bond. Having said that, then we can use the formula for duration to do some useful calculations. One of them is to use duration to calculate the expected change in the value of a bond. And you see that the expected change in the value of the bond given a change in the yield to maturity of the bond is a function of the negative of duration times the price or value of the bond times the change in the yield divided by 1 plus the yield to maturity of the bond. So what you should get out of this is that changes in bond values are inversely related to changes in the yield to maturity of the bond. And the amount of the change is directly proportional, or in this case would be, yes, it's directly proportional to the absolute size or the absolute value of the duration of the bond. So bonds that have larger times to maturity, i.e. larger durations, will be more sensitive to change to the same amount of change in the yield to maturity. So the change in the value will be larger for bonds that have much larger durations than the change will be for bonds that have much smaller durations. Another useful concept here is that if you divide duration by 1 plus the yield to maturity of the bond, then you get a measure called the modified duration of that bond. So it's easier to work with the modified duration because then you associate changes in the price of the bond directly to changes in the yield to maturity of that bond. And third, if you multiply the modified duration, which is this, times the value of the bond, then you get what's called the dollar duration of a bond. So, using all this, you realize that the dollar change in the price of a bond given a change in the yield to maturity of that bond is directly proportional to the dollar modified duration of that bond. Now, if this change in yield is 1 basis point, that is 1/100th of 1%, then that change in value of the bond is called the price value of a basis point for that bond. So the change in the bond in response to a 1 basis point is called the price value of a basis point. Of course, we've been talking about the duration, which is a measure of the average maturity of the cash flows of a fixed income securities. But this is a derivatives seminar, and the question is, what is the duration of a futures contract? Well, remember that a futures contract on a fixed income security like a treasury bond, the underlying is a fixed income security. So the duration of a futures contract is actually the responsiveness of the cheapest to deliver at the expiration of that futures contract in response to changes in yields. In other words, it's the duration of a futures contract is the implied duration of the cheapest to delivery underlying of that futures contract. So the dollar duration for the futures is simply the dollar duration of the underlying divided by a conversion factor for the cheapest to deliver. And that's how you would calculate the modified duration, dollar duration of a futures contract, which in general will be given to you. Now that we've talked about duration and the duration of a fixed income security and also the duration of a futures contract whose underlying is a fixed income security, let's talk about hedging. What is it? Of course, by now you probably know what hedging is all about, but let's define it in a very operational way. Hedging is simply taking a position in the derivative market that is opposite to the one you have in the cash market. That's simply what it is. You take a position in the derivative that is exactly the opposite position of the one you hold in the cash market. And what is the goal? Well, the goal of hedging is to reduce, or in many instances to eliminate, price risk or rate risk. In order to understand hedging a little better, we need to understand why convergence may or may not occur between the futures price and the spot price or the cash price. So let's talk about convergence. Remember that under no arbitrage opportunities, the price, the futures price, which is denoted as F sub t, 0t, and F sub t means this is the futures price at t, a small t, with maturity big T, is equal to the spot underlying price, or the cash price, times or plus the cost to carry. In this case, the cost to carry is obtained by multiplying the cash price times 1 plus R, which is the financial cost to carry, let's say, to the T minus T, which is the time to expiration between now, which is small t, and the expiration big T. So futures price under no arbitrage equals the cash price plus the cost to carry.